Your electric bill went up again this summer. The back bedroom never gets comfortable no matter where you set the thermostat. A contractor came out, looked at the air conditioner, and told you it was too small for the house, or worn out, or close to failing. So now you are holding a quote to replace the system, and it is not a small one. Before you sign that, understand what you are being sold. A forced air system has two halves. There is the equipment, which makes cold air, and there is the ductwork, which carries that air to the rooms. The equipment sits in a closet or on a slab at the side of the house, where you can see it and hear it. The ductwork runs through your attic, your crawl space, and the insides of your walls, where you have never once looked at it. You are about to replace the machine that makes the air, and nobody has checked the pipes that carry it. That's what this video is all about. A high bill, rooms that will not cooperate, and the component everybody blames is usually working exactly as designed. Before we get into it, I'm Wade, and this is a channel about houses, mostly about what gets blamed when something goes wrong in a house and whether it deserves it. Nobody gets quoted for the wrong repair because somebody lied to them. They get quoted for the wrong repair because the right one was harder to see. That's what this channel is for. What's actually wrong, what it actually means, and roughly what it actually costs. The number worth knowing comes from Energy Star, which is the Environmental Protection Agency's efficiency program, not a company selling anything. In a typical house, about 20 to 30% of the air moving through the duct system is lost. Leaks, holes, and poorly connected ducts. That has nothing to do with worn-out equipment or a system too small for the house. It is air the machine cooled, air you paid for, going somewhere other than the room it was addressed to. Energy Star is also specific about what that feels like from inside the house. You get higher utility bills and difficulty keeping the house comfortable no matter how the thermostat is set. That second half is the complaint people actually carry to a contractor. You turn it down, you wait, and the room barely changes. It feels like the equipment has quit. What it actually describes is a delivery failure. Now consider the scale of what is being lost. The Energy Information Administration surveys how American households really use energy. In the most recent one, space heating and air conditioning together came to 52% of a household's annual energy consumption. Those two things alone. Water heating, lighting, and refrigeration together were 25%. Everything else in the building, the televisions, the cooking, the laundry, the whole growing pile of electronics came to 23%. So the largest single item on your energy bill is conditioned air, and a fifth to a third of it is being delivered somewhere that is not your house. Duct leakage runs in two directions, and only one of them is obvious. The supply side is the half people can picture. Those are the ducts carrying cooled air out to the registers in your floors and ceilings. Every joint along that run is a place where air can leave early. When a supply duct leaks in an attic, you have paid to cool a volume of air and then released it into the hottest and least useful space in the building. The room at the end of that run gets whatever survived. The return side is where it gets strange, and this is the half almost nobody thinks about. Returns are the ducts pulling air back to the equipment to be cooled again. They are under negative pressure. They do not push air out, they pull air in. So when a return duct leaks in a hot attic in July, it is not losing your cool air. It is drawing attic air into the system. Air that has been sitting under a roof deck in the sun since 10 in the morning. That air goes to the equipment and the equipment cools it, because cooling whatever arrives is all it does. You are paying to air condition your attic a little at a time and then blowing the result into your living room. In winter, the same leak runs the other way. Cold crawl space air, damp and dusty, pulled in and heated on your dime. None of this makes a noise. Nothing trips, nothing throws a code, no light comes on. Nothing reports it, because by every measure the equipment has, nothing is wrong. It is handed warm air and it cools it. It will do that all day, in longer and longer cycles, and the only places it shows up are a bill and a room that never quite gets there. How badly this hurts you depends almost entirely on one thing, which is where the ducts run. If your ductwork stays inside the conditioned part of the house, between floors, inside interior walls, in a basement you heat and cool anyway, then a leak is still wasteful. The air is not going where it was sent, and the rooms at the end of the run still starve. But the air is lost into the house. Some of it finds its way back to you. If the ducts run through an attic, a vented crawl space, or an attached garage, it is gone. Outdoors, nothing recovered. Research from Penn State's Housing Research Center back in the mid-90s put the loss for duct systems passing through unconditioned space at roughly 30 to 40% of the energy delivered into them. About half of that is air leakage. The rest is conduction, which is heat simply moving through the duct wall into whatever is around it. Which is where the attic ventilation video comes back around. An attic with blocked soffit intake runs hot. Much hotter than the air outside on a sunny afternoon. Now run a metal duct full of cold air through the middle of that. The leaks lose air into it, and the metal absorbs heat from it, and the air arriving at your register is warmer than the air that left the equipment. A ventilation problem in the attic and a comfort problem in the bedroom are the same problem, separated by a ceiling. Now here is the part that ought to bother you. Say you buy the new unit. It is bigger, newer, and carries a better efficiency rating than the thing it replaced. It gets connected to the same ductwork because the ductwork is in the walls and the attic, and replacing it is a different job entirely, one with drywall in it. The leaks are still there. The fraction does not change. If the system was losing a quarter of its air before, it loses a quarter of its air now. You have bought a machine that makes more air so that a quarter of a larger number can go into your attic. The room that never got comfortable still is not comfortable. The equipment was always capable of producing enough cold air. The question was only ever how much of it arrived. And this one irritates me more than most things in this business, because nobody has to be lying for it to happen. Replacing a unit is a clean job. It is quotable, it is schedulable, the part comes off a truck, and the customer can stand there and look at the new thing when it is finished. Testing and sealing ductwork is fiddly. It happens in a crawl space, and half of it is invisible when it is done. The incentives point at the equipment. They point there whether or not the equipment is the problem. You can gather a fair amount of this yourself, with no tools and without going anywhere you should not be. Start with the pattern of the complaints. Rooms that never reach temperature regardless of thermostat setting is the symptom Energy Star names outright. Pay attention to which rooms. The farther a room sits from the equipment, the longer its duct runs and the more joints that run contains. If your problem rooms are the ones at the far end of the house, that is a distribution pattern, not an equipment pattern. Then go look at whatever ductwork you can already see. A basement, a garage ceiling, a utility room, whatever is visible through a crawlspace hatch from where you are standing. Do not go into an attic or a crawlspace for this. It is not worth it, and there is nothing in there you need. When you look at the joints. Where two sections meet, where a branch tees off the main trunk, where the duct connects to the boot behind a register. Leaks happen at connections. The middle of a straight run is rarely the trouble. And if you find cloth-backed duct tape wrapped around a joint, that is bad news rather than good. Energy Star says plainly never to use duct tape on ducts because it does not last. It dries out, the adhesive quits, and it peels away. Its presence tells you two things. Somebody knew there was a leak at that joint, and they reached for the wrong material. Mastic or metal tape is what belongs there. There is one more sign, and it shows up in the housekeeping. A room that gets dusty noticeably faster than the rest of the house can point toward return side leakage, pulling unfiltered air in from wherever that duct passes through. Measurement exists, and it is routine. It is called a duct leakage test. The ducts get pressurized, the leakage gets measured, and the answer comes back as a number instead of an opinion. Home performance contractors and energy auditors do this. Plenty of heating and cooling companies do as well, though not all of them offer it and fewer volunteer it. The question worth asking is short, and you put it to the contractor before anyone quotes you a number. Has anybody measured the duct system? That question separates a diagnosis from a sale. Not because the answer is always no, and not because anybody is trying something on you. Plenty of contractors will say, yes, here is what we found, and here is why the equipment still needs replacing. That is a fine answer. What you are checking is whether anyone examined the delivery side before condemning the production side. If nobody has measured it, you do not have a diagnosis. You have a quote. So there is a high bill, rooms that will not come to temperature, and a recommendation to replace the equipment. The equipment is the visible half. The other half runs through spaces you never enter, and in a typical house, it loses somewhere between a fifth and the third of what it is handed. That does not mean your unit is fine. Sometimes a unit is genuinely finished. It means you do not know yet, and neither does anybody who is not measured. So here's one thing to do today. Go stand wherever your ductwork is visible: basement, garage, laundry room. Do not crawl anywhere. Find a joint, a spot where two pieces of metal or flex duct meet, and look at how it was put together. Look at 4 or 5 of them. Whatever you find there is a fair sample of what the rest of it looks like in the places you cannot see. If you do go and look at those joints, tell me what you found down there. And if somebody has already quoted you for a new system, say whether anybody mentioned the ductwork before that number got written down. I suspect a lot of you know the answer to that one already. If this made you look at that quote differently, like the video and subscribe. There's more of this coming.